world is intrigued by fossils. I've always enjoyed the fossil digs, carrying the young people with me and watching their eyes light up as they find something really significant. Watch them imagine these creatures as they lived not in the not too distant past, I believe. The fossil record, many have been convinced, says evolution, and many Christians are intimidated by that. I think the actual record says exactly the opposite. I think when you look at billions and billions of dead things in rocks laid down by water all over the world, you're seeing a record of judgment rather than a record of evolution. This is the alternative view. But we want to look at the evidence from the fossil record today. If there is evidence of evolution, then this would be where you would find it, in the fossil record. And we're told over and over again that the fossil record actually proves evolution. It is the critical evidence. S.M. Stanley from Johns Hopkins University says it's doubtful whether in the absence of fossils, the idea of evolution would represent anything more than an outrageous hypothesis. He says the fossil record, and only the fossil record, provides direct evidence of major sequential changes in the Earth's biota. This is where it's at, if you please. If there is proof, it would have to be here. And I hope you remember that statement. We'll refer to it later when we begin to see that that evidence does not favor evolution and that they are without the fossil evidence as far as support for evolution. Let's also remember a point that's made by John Horner. He's the paleontologist whose life was reflected in the Jurassic Park. He was the real-life character represented as digging up fossils in Montana. He says paleontology is a historical science, a science based on circumstantial evidence after the fact. We can never reach hard and fast conclusions. These days, it's easy to go through school for a good many years, sometimes through college, without ever hearing that some sciences are historical or are by nature inconclusive. Science involves what you can repeat. That is, when you reach scientific proof, conclusions in science, it's as a result of experimentation, observation, repeatability. You can't do that when you're evolving from an ape to a man, for example. That's not repeated in the laboratory. And so this is historical. The evidence, the only only conclusive evidence, is not going to provide conclusive proof. However, we do make predictions and we can learn a great deal, and it is a scientific investigation when we look at the evidence and compare the models. And one of the ways to compare models is to look at the predictions that are made by the two models. When we consider the fossil record, there are very obvious opposite predictions that are made by the two models. If you are an evolutionist, you would predict a simple beginning, a gradual progression upward, linked through things that are kin. This predicts the nature of the record in the beginning, and then the creation model would predict the opposite, the complex, abrupt beginning. They would be diverse from the start, and we should be able to look at the fossil record and tell the difference. It should be relatively simple. As we look at the continuing record, there would be predictions of similarities by the evolutionist, indicating kinship, but they would be branching similarities, as kinship would necessarily imply, and an allied continuum. While on the other hand, the creationist would expect that there would be similarities, but they would be similarities not branching, but of a mosaic pattern, where the artist would use a blue tile here and then a blue tile there where he needs it, similar but not connected, as a designer would do. Again, there would be similarities, but they would be separate and distinct, and stasis would be the order of the day rather than continuing change. Stasis, status quo, stays the same, fancy word used by evolutionists or by many scientists. Now, as we look at the two models, and as we see the different predictions, And I tell you what the fossil record is, you might say, well, you're prejudiced. I would tell you that it favors the predictions of the evolutionists. But we're going to allow the evolutionists to describe the evidence for us. The quotes that we'll be using will be from the antagonistic witness. And some people misunderstand this concept. They say, well, you're not being fair. You're using people that disagree with you. But that's the point. That provides even stronger, better evidence. For example, when you're in court and you have a friendly witness who testifies on your behalf, and he says the accused is honest and he has no reasonable motive to lie, that'll help. But if, on the other hand, you have an antagonistic witness who makes these points, then the evidence is much stronger when he says the accused is honest, there's no reasonable motive to lie. In other words, when you have friendly testimony, that helps. But if you have acknowledgments contrary to interest, you have much greater weight given to the testimony. And the evidence that we're going to be giving then would be those who are testifying contrary to their interest. They're quotes from antagonistic witnesses. We want you to understand they're from devout believers, but they're believers in evolution. They are men of great faith, but they're men of faith in evolution. We'll begin with Richard Dawkins, who would certainly qualify as an evolutionist, a creation hater, I think is a fair statement, and we'll see statements from him that justify that. He's from Cambridge. He wrote the book, The Blind Watchmaker. In it, he describes the beginning of the fossil record. He says, and we find many of them already in an advanced state of evolution the very first time they appear. It is as though they were just planted there without any evolutionary history. Needless to say, this appearance of sudden planting has delighted the creationist. Yes, well, I would plead guilty there. They begin, he has faith that it's an evolutionary appearance, but it's not because of an evolutionary record. That's not there. It appears without that record, without any evolutionary history. And that's, of course, exactly what we would predict. Notice the depiction by National Geographic in this page, Explosion of Life, describing the lowest, the beginning layer of the fossil record, that is where the fossils begin in abundance, in the Cambrian, the bottom of the geologic column. This is an explosion of life, and that's a term that's typical in describing that. We'll see more about why that's justified in a moment. One of the more typical fossils found there would be the trilobite. Probably more trilobites than anything else there in the Cambrian. Way back in 1974, here we see a description of trilobite eyes. You typically don't see this in the textbooks, but here in Science News, they may have been superior to current living animals, that is, in their eyes. They had, in principle, perfect vision. They possessed the most sophisticated eyes ever produced by nature. They looked like they were designed by a physicist. Now, again, I didn't write this, but if I had written it, I couldn't have done better. This is the most typical fossil in the lowest part of the geologic column, the beginning of the fossil record, and we see as sophisticated a part of our anatomy as you can find, and it's superior. Notice the description by Stephen Gould of Harvard, one of the more famous evolutionists of our time, recently deceased. He says the Cambrian explosion occurred at a geological moment, and we have reasons to think that all major anatomical designs may have made their evolutionary appearance at that time. Now, it was an evolutionary appearance, but all of the anatomy, designs of anatomy, he would use that term, appeared right from the beginning. That's at the start. Not only the phylum Chordata itself, but all of its major divisions. Chordata, that's the division that we're in, the animals with backbones, and all of the major divisions. And where is that? That's at the beginning. Now, I couldn't have written the story better myself. Continuing, he says, since the so-called Cambrian explosion, no new phyla of animals have entered the fossil record. So you have them all right at the beginning, and no new ones since. Now, what does that sound like, honestly? As you look at the different predictions made by the creationist and the evolutionist, which one is served best by the evidence? Here's a summary of statements that the evolutionists make regarding the beginning of the fossil record. It's complex, it's sudden right at the start, advanced as if they were planted there, according to Dawkins. Land plants, we have 60 genera of land plants. Many books will say that in the Cambrian there's nothing but shallow seas everywhere. We have fossils of land plants. That's obviously not accurate. Vascular plants, 6 different groups of the woody type plants. And then all the major anatomical designs, the chordata, all of its major divisions. We have vertebrates from a number of states across the country, and the article documenting that was published in '78. This is not new news. Vertebrates, animals with backbones from all of these places across the country. Since the Cambrian explosion, no new phylum. I'm sorry, I think it's obvious which model is served best, and this is not my description. This is the description of the evolutionist, the antagonistic witness about the most critical part of the fossil record, the beginning of that record. And furthermore, not only do we find complex animals right from the start, animals that would live at the bottom of the ocean, I think it's the beginning of a flood deposit, but we find that those animals are distinct and separate right from the start. Quoting here from Discover magazine, demonstrates that the large animal phyla of today were already present in the early Cambrian, and that they were distinct from each other as they are today. Menagerie of clam cousins, sponges, segmented worms, other invertebrates that would be vaguely familiar to any scuba diver. If you go down to the bottom of the ocean, that's what you find in the Cambrian. But it's there today, and they're distinct and separate then as today. But in the textbooks, you see a very different representation. It's always illustrated with the simple things at the bottom. The complex things are not till you get to the top, and they're all graduated and connected in this branching pattern. That's not what the fossils say. And if you're interested in the implications of the fossil record, you can just X this out. This is not the record of the fossils. Stephen Gould says this very plainly. He says the evolutionary trees that adorn our textbooks have data only at the tips and nodes of their branches, not the evidence of the fossils. The rest is inference, he says, however reasonable. But it is not from the fossils that you find these textbook-type trees that show the graduated progression. In fact, if you turn the tree upside down, you have a closer representation. He says it starts broad and goes downhill. The sweep of anatomical diversity is reached a maximum right after the initial diversification of multicellular animals. A fancy way of saying we had more diverse anatomy from the start. He goes on to say the later history proceeded by elimination, not expansion. It's a downhill process from a more complex and broad and diverse beginning. If you look at what Gould calls the cone of diversity, you see what's predicted in the fossil record, gradually starting from a simple beginning and getting more diverse and complex as you proceed through time. The actual truth, and these are diagrams that you'll find in Gould's book, is like this. We had more in the past, it's gone downhill to the point where we are now. But compare that again with what we see in the textbook, this gradual upward progression, which is the very thing that he says is not in the fossil record. Well, if this is not in the fossil record, where did it come from? What's the source of this kind of a representation? Again, let's allow the evolutionist to describe that for us. Here in Patton's book, Evolution of the Earth, that I was taught from at 2 different major state universities, we have arranged the groups in a traditional way with the simplest forms first. How did they get that way? Well, we arranged them that way with the progressively more complex groups following. The particular arrangement is arbitrary and depends on what definition of complexity you wish to choose. Now, this may be somewhat oversimplifying, and we don't want to misrepresent. This is their statement. But they go on the same page to describe really the basis for this. It's not the fossil record. It's arbitrary. It's something that they arranged, but the arrangement does have logic to it. He says things are alike because they are related. The less they look alike, the further removed they are from the common ancestor. And so this similarity allows them to arrange this into the family tree. Well, it's not that simple, because it's certain similarities excluding other similarities. And then, well, there's a lot of ignoring of evidence that goes on in that process. But this is the way it's represented. And I've been in class where I've been scolded. Don't you know that kin, cousins, brothers and sisters look alike? And, well, yes, we understand that. We see that as a possible explanation. And when we look at apes and men, for example, can there be any denial that there is a very dramatic similarity here? This is obvious. We can see dissimilarities, but honestly, the similarities are much more dramatic. The question is why? Well, the evolutionist seldom asks that question. He just knows that it's because of common ancestors. But that's not necessarily the only explanation. In fact, I believe there's a better explanation when we look at all the similarities. You drive down the street and you see houses that appear similar because they're cousins. Right, well, no, that's not the case. They had a common designer. That's a much better explanation. And when we look at the record of anatomy, when we look at animals in the animal kingdom, we see similarities. We're often referred to the pendactyl form of the vertebrate hand. And yes, that's obvious. We see, but again, why? You can explain it in terms of common ancestry or in terms of common designer. Actually, common designer doesn't work, that is, works much better here. Common genetics doesn't work because if they were from common genetics, they would come from the same parts of the embryo. The embryo would develop this way the beginnings of the hand would develop, and it would be the same in the rabbit as in the pigeon and in the frog, and we see the results being similar. But if it's from common genetics, it ought to be from common beginnings in the embryo, and that's not the case. In the newt, it's from segments 2 through 5. In the man, it's from segments 13 through 18. That is, that segment in the embryo produces the hand. It's a different segment in the embryo that produces the hand in the newt, and from the lizard it's 6 through 9. It doesn't appear to be from common genetics. Common designer seems to work better, and there are other reasons for that as well. The argument from similarity we want to spend some time in. We're talking about the fossil record, but the only way that fossils mean anything in terms of creation or evolution is if you infer something, and for the evolutionist, it's being inferred from similarity. And this principle of similarity is what is the ball game. That's what makes them say something besides dead things in rocks. Similarities, though, lead us astray in many instances. There were arguments made in the past, for example, from chromosomes. We look at the order that's indicated here. Humans have 46, Penicillium 2, the opossum 22. Okay, it looks like an evolutionary progression here. See, the similarity in the order shows a progression upward toward man, until we look at the rest of the story. And now then, this argument is, while it's still in a few textbooks, it's generally been dropped because we find, yes, human has 46, but the chimp has more, 46. The fern has 480. The turkey has 82. Well, that doesn't look quite like the evolutionist would predict, and so typically that's, when you look at the whole picture, it begins to look a little different. Sometimes we're told we need to look at the amount of DNA, and that would show an evolutionary progression. Compared with humans, we see the euglena has about the same amount of DNA as we do. The liverwort, a moss-like plant, has 18 times as much, and here's a salamander that has 26 times as much. Well, that didn't help a whole lot either in terms of supporting evolution. This argument from similarity has been used since the beginning, and back shortly after Darwin's time, Haeckel came up with this famous argument that's been in thousands of textbooks, and it touts the similarity of embryos in the beginning of their development. And we see up at the top of the chart that these embryos are drawn to look very, very similar, but they develop into very different organisms, the pig and the fish and the salamander and the man. And that's been shown in textbook. And I've had people say, well, this development from embryo, they came from the same kind of embryo, shows an evolutionary progression. I don't think it's necessarily, it necessarily follows, even if this were true, but it isn't. You've been lied to, unfortunately. This is the statement that we see emphasized here in the Times in London. The headlines just a few years ago, embryonic liar. It shows the embryos up at the top as drawn by Haeckel, very similar, back in Darwin's time. And in fact, Darwin referred to this argument and said he thought it was one of the best that he knew of. But compared with what's at the bottom, we see the actual pictures of these embryos that are supposed to be represented in the drawings, and they don't look similar at all. And so the Times just says the fellow's lying about this. We look in New Scientist, who reported the same kind of things. Here is fraud rediscovered, and we see the drawings down below and the actual embryos up at the top. This is fraud, and that's the only way to describe it. Notice the quotation from New Scientist. Although Haeckel confessed and was convicted of fraud. Now, this is not my assessment. This is what we read in New Scientist. He was convicted of fraud at the University of Jena. The drawings persist. That's the real mystery, Richardson said, and he's complaining about this in New Scientist, and certainly they do persist. Here's one of the more common biology textbooks that's used in our schools today, and sure enough, right there in with their bare face hanging out is this same drawings that Haeckel used 100 years ago to deceive. These similarities don't exist. Of course, there are similarities. Those don't. We're often referred to the similarity between apes and men with the DNA, and we're told the genome of ape and man is 99% similar, and this is supposed to prove that we came from a common ancestor. Well, this has been grossly exaggerated and corrected, though not in headlines. Here back in 2004 in Nature, they said they found 83% differences in the 231 genes that they compared between ape and men when they're looking at the amino acid sequence of the proteins, and then said 20% showed significant structural changes. Well, that's obviously considerably more than 1%. And as they pointed out, we've seen a much higher percentage of change than people speculated. And so this has been misrepresented. But let's just assume that that were true, and we often hear it repeated. It isn't, as we've seen. But we're told specifically there's 1.6% difference in the genome of the ape and man. But think about that for a moment. There are 3 billion nucleotides in the genome, 3 billion bits of information. That's 48 million nucleotides when we're talking about 1.6%. Now, how much difference would 48 million nucleotides make? Well, think about that in terms of cystic fibrosis, a terrible disease that is relentlessly fatal. That involves not 1% or 1.6%, but 1/10000000th of 1% of the genome. That's 3 nucleotides, not 48 million. With sickle cell anemia, we're looking at 1/3 of a billionth of 1%. That's 1 nucleotide. And yet we're told that it's only 1.6%. Of course, that's 48 million nucleotides when 1 produces a fatal disease, sickle cell anemia, and 3 produces cystic fibrosis. You're going to change 48 million, and it doesn't matter. It's not much difference. You randomly change 48 million nucleotides, and you have obvious disaster. There are dramatic similarities, and when we look, for example, at sheep, here is from a news report back in 2000, Sue Galloway University of Ontario and University of Finland. Sheep are 98% the same. Our genes are the same, we're told. And then mice. Here's reported in the National Human Genome Research Project. Overall, mice and humans share virtually the same set of genes. This was in 2006. On the average, and speaking of an average here, coding regions, the genomes are 85% identical. Some are 99% identical with mice. Well, we're proving more than the evolutionist is intending to prove here when we're looking at similarities. I think common design does a better job. Thinking about the implications, the logic involved here, what does similarity prove? You look at these two fish, they appear similar. What does it prove? Well, actually, neither one of them are fish. This one is a reptile, and then this one is a mammal, the one at the bottom. Neither one of them are fish. Both of them are similar to fish. None of neither the reptile, the mammal, or the fish are kin, but they look very similar, proving, well, we just leave those out when it comes to lining up the tree. And then we look at the poor critter represented here, the platypus, who's kin to almost everybody, according to this interpretation. We see that he's like a bird, he's like mammals, he's like a paddlefish, a mammal, and just all kinds of similarities. The duck and fur like a beaver. He's kin to everybody. The old adage, that which proves too much proves nothing, is, I think, very apropos at this point. When we find similarities that don't count, that you don't look at, that you ignore, then that's called parallelisms. And that's not giving a solution to the problem, that's just naming the problem. And that's typical. Notice the statement here by Dr. Young, professor at Oxford. He refers to the fact there are similar features and they appear in distinct lines, and it's so common, it's almost a rule. Any detailed study of any group, this is going to confuse when you try to line them up, because you've got to eliminate those that are kin, that is, those that aren't kin but are very similar. And you're unable to distinguish, he says, those that are parallel and those that are descended. Well, what it amounts to is, if it fits the scenario of evolution, then they'll use the similarities. If it doesn't fit, then it's parallel and you don't use it. And that's not science. When you look at all of the picture, we saw with the chromosomes a moment ago, when you just look at part of the picture, then you can tell just about any tale you want. But when you look at the whole picture, it's very different. We're often referred to the blood serum of the chimpanzee, and yes, it's very similar. And if the right anti-serum is used, yes, you can actually interchange and use this as a human being. But when you look at milk chemistry, we see a significant difference with the chimpanzee. Our closest kin there turns out to be the donkey, which again doesn't fit the scenario the evolutionist would predict. In terms of cholesterol that we're all interested in, well, the garter snake has cholesterol just like we do. In terms of foot structure, we're interested in that in our efforts down at Glen Rose. As we look at the fossil footprints, we're looking for animals that might have made this. Sometimes we're told maybe an ape made them. Well, an ape has a hand for a foot. He doesn't have a foot like ours, but the glacial bear has a foot almost identical. If you put it as a mirror image, the thumb's big toe is on the outside instead of the inside, and of course he has claws and he's a quadruped. But if you remove the claws and put it in a mirror and remove the flesh, wow, it's just virtually identical, unlike the ape. In terms of tear enzyme, lo and behold, the chicken has a very complex enzyme, lysosome, just like we do, designed, I think, to attack the bacteria. We need it in our eyes, the chicken needs it in the egg. And here's that mosaic pattern where the designer uses the blue tile here where he wants it and the blue tile there where he wants it. Yes, similarities, but not in a branching pattern. When you look at all of the picture, you see that branching pattern does not describe the similarities that we're looking at. In terms of blood antigen A, lo and behold, the butter bean. has blood antigen A like we do, and wow, brain hormone, the cockroach has a brain hormone just like we do. Here's a statement from Discover magazine saying, "Don't squash that roach, he may be your cousin." We're told the roach has a brain hormone just like ours, identical. It is the same. Now, they don't really put that in this tree and use that to line up the similarities. They leave out significant similarities to paint whatever picture they want. There was a cartoon back in Darwin's time that I think clearly illustrates this point. You begin with a pig and change that pig just gradually, and you can finally wind up looking like a bull. And that bull continues to change just a little bit, and it's obvious then that man evolved from the pig by way of the bull. And here's the proof. It's scientifically proved. See the diagram? It's the same kind of diagram that you see in the textbooks that's supposed to prove, supposed to be scientific evidence. You just line them up. See how they line up? What have you proved? Well, you're looking at similarities, ignoring other similarities, and lining them up according to the scenario. Now, this may make an interesting model that you can then test, but it's not proof. And don't look at it as proof when you see that in the textbooks. Summarizing then, in our first session on the fossils, this is the evidence. This, without it, it's just an outrageous hypothesis, as Stanley says. But when we look at the critical beginning of the fossil record, it's complex, it is abrupt, it is diverse. We have all of the major phyla right at the beginning. There have been none new since. The trees of life in the textbooks are from selected similarities. They're not from the fossils, they're not from embryology, they're not from genetics, and the similarities that are used to build the trees reveal a mosaic pattern, not a branching pattern. Now, when we look at that picture, the critical evidence is much more in favor of the creation model than the evolution model. It fits the facts best as described by the antagonistic witness. And so you can see why I like to talk about the fossils. I think they speak very clearly of a sudden complex beginning, not gradual progression over millions of years. The fossil record provides positive evidence for a sudden complex beginning as opposed to a gradual sequence developing over millions of years. I think the creationist can delight in what the fossils tell us. The evolutionists sometimes try to intimidate and tell us that's in favor of evolution, but when you look at what the experts have to say about the matter, you find that's really not the case at all. In the first session, we showed the nature of the beginning of the fossil record, the sudden complex beginning, the distinct separate types right from the start. Arranged similarities tell us of a tree, but they do not come from the fossil record. They're in spite of the fossil record. But if we look at the fossil record in general, after we get past the beginning, just ignoring that problem, how do we see evolution as we look at the fossils that we dig up? Well, we would need to be able to see transitional forms in order to see evolution, things changing from one to the other, and that would be in the form of the transitions. What we see actually is described as stasis, according to Stephen Gould, again, one of the leading experts in evolution in our country from Harvard. He says every paleontologist knows that most species don't change. Now, of course, evolution is change, but most species don't do that, he says. That's bothersome, of course, to the evolutionist. That brings terrible distress. I regard the failure, he says, writing in Natural History, to find a clear vector of progress in life's history as one of the most puzzling facts of the fossil record. Well, of course, that's puzzling to him, and it's a failure for the evolutionary prediction. It is just the opposite for the creationist, who is delighted by such evidence, as he describes. He continues saying, "We have sought to impose a pattern that we hope to find on a world that does not really display it." The pattern, of course, being evolutionary progression. He's puzzled by the failure to find that. Now, again, that's his description of what we see there. It's the opposite of change that would be predicted. He says in Natural History, we can tell tales of improvement for some groups, but in honest moments, we must admit that the history of complex life is more a story of multifarious variations about a set of basic designs than a saga of accumulating excellence. Now, he uses the word design, though to be fair to him, he doesn't believe they were designed. That's what they look like. He chose that term. But they're telling tales when they tell of this tree of life that progresses upward. That's not from the fossils. What you really see is just variation about a set of basic designs. And this is not new knowledge. Darwin understood this. Back in Origin of the Species, he says innumerable transitional forms must have existed, but why do we not find them embedded in countless numbers in the crust of the earth? Why is not every geological formation and every stratum full of such intermediate links? And of course, if his view of the fossil record is true, then that's exactly what should be found. And he understands, yes, that's what we should see. That's the only way we can see change or evolution in the fossil record, these transitional forms. And there should be more transitional forms since they were leading to the others constantly, but that's not the case. Geology assuredly does not reveal any such finely graduated organic chain, and this is perhaps the greatest objection which can be urged against my theory. Now, many people think Darwin looked at the fossil record and said, here's proof, but no, he saw this as his biggest problem, and it's gotten worse. Many times people will say, well, it has gotten better. Darwin recognized the problem, but notice the statement by David Rapp of the Chicago Field Museum of Natural History. He's curator of the largest fossil museum in the United States. And he says Darwin was completely aware of this. He was embarrassed by the fossil record because it didn't look the way he predicted it would. He continues saying, well, we're now about 120 years after Darwin, and knowledge of the fossil record has been greatly expanded. We now have 250,000 fossil species, but the situation hasn't changed much. He says, ironically, we have even fewer examples of evolutionary transitions than we had in Darwin's time. He says, by this I mean that the classic cases of Darwinian change in the fossil record, such as the evolution of the horse in North America, have had to be discarded or modified as the result of more detailed information. The classic cases we've lost. Now, that bit of knowledge hasn't made it to most of the textbooks. They still have the evolution of the horse as one of their star classic cases, but one by one they've dropped out, including this one. We've all seen the representation in the textbooks of the little horse that graduates up to the big one. Again, they leave out significant facts that these animals are found side by side up in Kansas in the same stratum. We excavated a 9-foot donkey from the fossil record out near Lubbock, Texas. That kind of messes up the little graduated horse chart. But basically, you're looking at small horses leading to big horses. Notice the description of this by Colin Patterson, and he's curator of the largest fossil museum in the world, recently deceased, senior paleontologist, though, at the British Museum of Natural History for many, many years. He said there have been an awful lot of stories, some more imaginative than others. The more famous example, now he's being interviewed, by the way, by Harper's Magazine. He's in the United States, and he's in the American Museum of Natural History in New York, being interviewed now by Harper's. The most famous example, still an exhibit downstairs, is the exhibit on horse evolution, prepared perhaps 50 years ago. That has been presented as the literal truth in textbook after textbook. And if you're familiar at all with the biology textbooks, earth science textbooks, you've certainly seen that representation. He says, I think that's lamentable, that is, that it's been in all of these textbooks, particularly when the people who show those kinds of stories may themselves be aware of the speculative nature of some of that stuff. He knows that this is not fact, that they have lined them up the way they want them to, even though they find them in the same layers, and that you don't know that one led to the other. It's just the way they tell the story. George Gaylord Simpson is probably the most authoritative source of information on horse evolution. He's the one that came up with this argument. He wrote the book on it. And in his book, Life of the Past, he says the uniform continuous transition of Hydrocotherium into Equus, that's what's pictured in the textbooks, so dear to the hearts of generations of textbook writers, never happened in nature. Now, here's the author of the story, and he says the way it's told in the textbooks never happened. It's lined up as the evolutionist wants it to be lined up, but what does the lineup prove? No more than lining up the pig to the bull to the man. Derek Eger, when this statement was made, was president of the British Geological Association. He says it must be significant that nearly all the evolutionary stories I learned as a student have now been debunked. And he refers to the horse story and to several others. But he does think that many of them, not many, that's not true. He thinks that a few of them, and that's the way he would describe it, are still valid, though most of them that he was taught as a student have been debunked. He refers to Archaeopteryx as perhaps the best example, and we see this in all the textbooks. Here's the half fossil, half a reptile, half bird. This is proof that the reptiles evolved into the birds, and we see this beautiful fossil specimen showing the feathers, I think, of an excellent bird. Some of the beautiful fossils of the feathers testify to that, and we see the wing here of a powered flyer, but we're told, look on the edge of its wings, it has claws. This proves it's primitive. Well, many birds in the fossil record had claws that lost them, and losing things they did have is not an evolutionary progression upward. That involves getting new things, not losing old things. But we do have many birds today. For instance, the Hoatzin maybe is the closest example down in South America that has claws on its wings in the juvenile form, and all of the examples of Archaeopteryx have been the juvenile form. The cassowary, the ostrich have claws on their wings, and so this is not unique and is something birds, the tern, for example, does, and that has lost them. That is, had them in the fossil record. But we're told, look at the teeth. This primitive bird has teeth, and the teeth prove he's primitive. Well, again, he's lost something, and when people lose their teeth, most don't think that's an evolutionary progression. Teeth are amazing structures, and when you study the formation of the teeth and the way the deciduous makes way for the permanent teeth, it's just mind-boggling to see, I think, the design involved in the structure. And birds have lost them. The tern, again, has beautiful teeth in the fossil record. Many of them do, and don't. They're beautiful, powered flyers today, but they've lost something, and that's not evolution. Many people look at that, I think, inside out. There are modern birds that have teeth today, and so it's not a completely unique situation. But I think the real answer to Archaeopteryx comes from the evolutionary perspective of time. I disagree with their views of time, but let's play the game their way and see how it comes out. If their view of the dating of these fossils is correct, there's a serious problem with a find that was made a number of years ago, here reported in Nature, 1986. The headline's "Fossil Bird Shakes Evolutionary Hypothesis." And here's a bird 75 million years older than Archaeopteryx. That's half again as old as Archaeopteryx was. And it's a bird. It's an excellent bird. Here it refers to the paleontologist at Texas Tech University, Dr. Chatterjee. He and I have worked together a couple of times. They have advanced avian features. This is a good bird that got there before Archaeopteryx did. Well, how can Archaeopteryx lead to the birds if the birds got there first? You can't have the kids older than the parents, you know. It just blows the theory entirely. And actually, this is not the only example of that being found. Birds have been found in a number of instances before, according to their interpretation. The things they've led to have appeared. W. Swenson, I think, sums it up very honestly. He's from Cambridge. In his book, Biology and Comparative Physiology of Birds, he says the origin of birds is largely a matter of deduction. There is no fossil evidence for the stages through which the remarkable change from reptile to bird was achieved. Now, as we think of the tremendous difference between us and something that's up flapping its wings and flying, what would it take to get us, or to get a reptile up and flying? Well, the birds have hollow bones. They have a completely different respiratory system and completely different circulatory system that's necessary to sustain the high rate of breathing and heartbeat and respiration, the high metabolism. It just takes a tremendous amount of change, and there's no evidence of the remarkable change. Now, that certainly doesn't speak well for an evolutionist trying to document change. D.B. Kitts, University of Oklahoma, says the fact that discontinuities, not continuities which would show progression, discontinuities are almost always and systematically present at the origin of really big categories. Now, you would see dissimilarities, you would see gaps in the fossil record due to random sampling and incomplete sampling if it's just random and spaced accidentally. But this is systematic and regular at the origin of really big categories. It's an item of genuinely historical knowledge. Now, D.B. Kitts is a devout evolutionist. He's writing in the journal Evolution and says this is systematic. Anytime you get something that's really different, then you have a gap. And we all know this, though we don't tell it to you in the textbooks typically. Evolution, he says, requires intermediate forms between species, and paleontology does not provide them. Now, if you listen to your earth science teacher, she may tell you that it does, but here is one of the leading authorities in the world writing in the journal Evolution saying you don't see that in the fossil record. David Swift, who is professor of paleontology at the University of Hawaii, writing again in his book Journal Evolution Under the Microscope, no phylum can be traced from a preceding one in the fossil record. We cannot account for the origin of a single phylum. They all appear abruptly. Now, he devoutly believes that they did evolve, but in terms of the fossil record, that's not the picture you see. This is also true of taxonomic groups such as classes, orders, possibly lower still. In other words, you got a major group, it's sudden, and probably true with its classes, orders, and even lower. You got something different, you got a gap. It doesn't lead from one to the other. Again, this is not the creationist telling you that. S.M. Stanley, a very famous paleontologist from Johns Hopkins, says there's not one. In fact, the fossil record does not convincingly document a single transitional form from one species to another. A.C. Stewart expresses the fact that he is confident that this is reality, that is, that it did happen, it did evolve. He says, the theoretically primitive type, though, eludes our grasp. And our faith postulates its existence, but the type fails to materialize. These are men of faith. I think they're men of great faith, but it's not based on the evidence, it's in spite of the lack of evidence. In fact, as one individual says, for the evolutionist, their faith is the substance of fossils hoped for, the evidence of links unseen. If you're familiar with the quotation from Hebrews, applied here to the evolutionist, theirs is not based on evidence. It's a blind faith, which I don't think is good faith, either religiously or scientifically. Niles Eldredge explains his justification for my statement. He says, it has been the paleontologist, my own breed, who have been responsible for letting ideas dominate reality. We paleontologists have said that the history of life supports that interpretation of gradual change, which is what he's talking about, all the while knowing that it does not. Now, that's what's required to show evolution, and so we told the story. As Gould says, we can tell stories about this, but in honest moments we have to admit it's just variation about basic designs. And here Niles Eldredge acknowledges that this is just not what we find in the fossil record. We know better, but we keep on telling the story. I don't think that's honest. I don't think it's good science. And when we look at the fossil record, we see why they're squirming and having trouble, because it's not saying what they want it to say. However, one of the reasons Stephen Gould is willing to admit some of these things and acknowledge that this is not really what I would like to see is that he thinks he now has an answer. He thinks he has a solution to the problem that you see a sudden complex beginning, and you see fossils that don't change, and you see gaps between all of the fossils. They're separate and distinct from the beginning, and they stay separate in the fossil record as in the living world. But he can answer that, and so now, he didn't really admit that before, but now then he's got an answer in punctuated equilibrium. Sounds very impressive, doesn't it? Actually, it's very similar to an idea that wasn't received quite so favorably back in the 30s. Goldsmith talked about the hopeful monster mechanism, and it was basically, well, it was a very similar idea. And Gould refers to him and says it's similar, and says he thinks Goldsmith would be vindicated. But Goldsmith essentially said, when you look at the fossil record and you see the sudden transition of one form to the other, then there must have been a reptile that somewhere laid an egg and a bird hatched out. And that's the way he said it. Well, the geneticist, and that was his field, laughed at him. They preferred to think that he's the one that laid the egg. Hopeful monsters didn't sound very scientific, but he says, well, that's what the fossil record looks like. And so Gould, building on that, said, yes, that's basically what happened. He thinks Goldsmith would be vindicated. But he doesn't call it hopeful monsters. It's punctuated equilibrium, and that, of course, sounds much more sophisticated. Gould and Eldredge wrote a very famous paper several years ago describing this, and in it they say, in fact, most published commentary on punctuated equilibria has been favorable. He says, we're especially pleased that several paleontologists now state with pride and with biological confidence a conclusion that had previously been simply embarrassing. All right, now what is it that they can now have pride in that used to be embarrassing? He says, all these years of work, and I haven't found any evolution. Well, if you're an evolutionist, that would be embarrassing. But they don't have to be embarrassed by that now. Not because he now finds the fossils that would solve the problem, but because he has an explanation for why they don't find it. He says, and we'll let Stephen Stanley, who is one who has written papers with them on this subject, describe the nature of what they believe. The record now reveals that species typically reveal, and when they say the record reveals, they're talking about something they've been forced to by the evidence and by very, very detailed studies with thousands of fossils documenting this point. The record now reveals that species typically survive for 100,000 generations, even 1,000,000 or more, without evolving very much. Of course, this is combined with their view of the time. But this is what we see, even assuming the time, that they survive without evolving very much. Now, what does that mean? We seem forced to conclude that most evolution takes place rapidly. Now, you might think that you're forced in a different direction. You look at the fossil record and you don't see change. You see over thousands of generations. They don't change. What does that prove? That things don't change? No, no, no. They don't challenge that. That's sacrosanct. Nobody is going to challenge that. We know that it happened, but we don't see change in the fossil. Well, then the solution is it must have happened rapidly. Never doubt that it happened. It just happened rapidly, and that's what they believe. Notice as he goes on to describe it, a punctuational model of evolution operated by natural mechanism, and notice he has to emphasize this is natural. It may sound supernatural, but no, this is, now he doesn't understand the mechanism, which he'll acknowledge, that made this dramatic change very quickly. But it's natural, whose major effects are wrought exactly where we're least able to study them, in small, isolated, transitory populations. So you don't see this, you can't see this, but we have faith that it happened there in these places where you can't look. The point is that if the transition was typically rapid and the population small, localized, fossil evidence of the event would never be found. And so they conclude you don't have to be embarrassed anymore because you don't expect to find the transitional forms. It happened so quick in these small, isolated areas that we don't even try to find it. Used to be embarrassing, but we're not embarrassed by that fact anymore because now we have an explanation. And so we're looking here at a story that explains why you don't have the fossils to support this transition from one to the other, and they have faced the fact they don't have a mechanism to make this dramatic change from one to the other, because the mechanism that's proposed in the textbooks is this gradual change, mutations being selected over millions of years. Gould addresses that when he says a mutation doesn't produce major new raw material. You don't make a new species by mutating the species. That's an idea people have, that evolution is due to random mutation. A mutation is not the cause. It can't produce this dramatic change that he's looking for, and so he's given up on it. In fact, he just says, look, this is deleterious. It is a change in a very complex system, random, accidental, like throwing a rock at your TV set. It's not likely to change it, and so this random, no, it's not going to produce a new mechanism, and so that's not it. So we don't have fossils, we don't have a mechanism. How valid is that kind of a concept of scientific change in terms of evaluating this by the scientific method? On the one hand, you've got fossils that you can't observe and don't expect to observe, and a mechanism that you don't know anything about and haven't seen. And on the other hand, you have observed fossils, thousands of them, that show distinct separate kinds, that show sudden complex beginning, that show they stay the same, they don't change, and mechanisms that we observe every day where kind produces kind produces kind. On the one hand, we have billions of fossils that we base our conclusions on, and we have mechanisms that we observe every day. On the other hand, you have mechanisms that you speculate about and haven't observed, and you have fossils that you don't expect to find. Now, just answer the question honestly. Which is better science? Scientists should go by the evidence. They should be compelled by the best explanation of the evidence, and that's not happening here. Philosophy is obviously dominating the ideas. Colin Patterson shows his understanding of this solution, his opinion of it, when he says, well, it seems to me they have accepted that the fossil record doesn't give them the support they would value, so they searched around to find another model and found one. When you haven't got the evidence, you make up a story that will fit the lack of evidence. Now, that may sound rather jaded, but that's his view, and I think he's right on. Again, the curator of the largest fossil museum in the world. When you don't have the evidence, you just make up a story. And when you talk about punctuated equilibrium, that's what you've got. You've got a story about why you don't find the evidence. It is not based on the evidence, but the lack of it. Notice D.B. Kitt's statement again. The claim is made that paleontology provides a direct way to get at the major events of organic history, and that furthermore it provides a means of testing evolutionary theories. The paleontologist can provide us with knowledge that cannot be provided by biological principles alone, but he cannot provide us with evolution. If you're honest about the fossil record, this evolutionist writing in the journal Evolution makes a very honest statement. You don't see evolution in the fossil record. You didn't see it in Darwin's time. That was the biggest problem he had, as he acknowledged, and it's gotten worse since then, as even the cases that he would point to have fallen by the wayside one by one. You can't see it in the fossil record, and you make up stories about why it's not there, which is what's being done. And some, well, let's look at one more tack that's taken by Mark Ridley of Oxford. Totally different approach. He says a lot of people just do not know what evidence the theory of evolution stands upon. They think the main evidence is the gradual descent of one species from another in the fossil record. Yes, this is exactly what we're told, and without the fossils that show progression proving evolution, it would just be an outrageous hypothesis. I think if you're going to prove it, that's where you have to go, even though it's circumstantial and historical, but nevertheless, that's the evidence, and we're told if there's proof, that's where it'd have to be. Well, he says, that's what you think, but you just don't understand it. He says, in any case, no real evolutionist, whether gradualist or punctuationalist, uses the fossil record as evidence in favor of the theory of evolution as opposed to special creation. No evolutionist thinks this way. Well, obviously they do, but he's tried and he's tried and he's tried. It reminds me of the story of the fox in Aesop's fable who's tried to reach up and get the grapes, and he desperately tried and over again failed, and just finds out he can't do it and walks off saying, those grapes are sour, I didn't want them anyway. You try for hundreds of years to document evolution from the fossil record, and you finally find out with more evidence that it's just not possible. Well, nobody wants those fossils. We don't use fossils. Nobody uses those fossils. I think it's rather comical. It's interesting, but it is true that you can't use the fossils to do it. As E.J.H. Corner of Cambridge acknowledges, much evidence can be adduced in favor of the theory of evolution from biology, biogeography, paleontology, but I still think, to the unprejudiced, the fossil record of the plants is in favor of special creation. And why would he say that? It's in favor of special creation because he sees the sudden complex beginning. He sees distinct separate types from the start. He doesn't see change from one group to another group. He sees stasis as the rule. That's exactly what we predict, and that's exactly what you find. And if you're going to base your conclusions on the facts, that's where you'll have to rest. The evidence, the only way you could document evolution documents, I think, the opposite. When you look at the critical beginning, the sudden, complex, diverse beginning, showing all phyla and no new since, including the major divisions and classes and orders, distinct and separate. Yes, trees of life are in the textbook, but they're from very selected similarities, ignoring others, And those are not based on the arrangement found in the fossil record. They're not from embryology, and they're not from genetics. When you look at similarities, yes, you can see them, but they're in a mosaic pattern. They're not in a branching pattern. Now, that's the evidence of the fossils, as we've seen. Noting the creationist comments, they delight the creationist. They embarrass the evolutionist. These are their terms. And yes, it is embarrassing. It was embarrassing to Darwin. It's more embarrassing now. It's delightful, as Dawkins says to the creationist. And then he says that it was Darwin's biggest problem. Now then it's worse, according to Rapp. The links that we were taught in graduate school have been debunked one after another. It's blind faith, as they describe it, that says evolution. We believe it. We make up stories to explain why there's a lack of evidence, and we have devout faith. But when you just base your conclusions on the facts, you have to say the fossils favor creation. It's a much better explanation of the facts. And that's why I teach, I believe, and demonstrate when we go out and dig up the fossils and when we look at all that have been dug up, that the fossil record is very strongly in favor of creation. Many times people say, well, creationists just object to evolution. They don't have any positive evidence. We have hundreds of thousands of fossils in the museum today which provide positive evidence for a sudden complex beginning and against a gradual slow development over millions of years. I love the fossil record, and I think it is one of the most delightful things that I know about, and certainly in favor of creation.